Welcome to Study Loop.
In this problem, on the topic of waves and sound, we have a graph which shows two waves traveling to the right at the same speed. If we use the data in the drawing, we want to find the wavelength of each wave, the speed of the waves is given, and then we want to find the frequency of each wave, and finally the maximum speed for a particle attached to each wave. Now, we know firstly that the wavelength is the horizontal distance between two successive crests. We can also see that the distance between successive crests of wave B is 2 times greater than that of wave A. And so the wavelength of wave B is twice as long. So from the drawing, we can determine the wavelength of each wave. The wavelength of A, we can see, is 2 meters. And we know that the wavelength of B is twice as large. So lambda B is equal to 4 meters. And those are the wavelengths of waves A and B. Next, we are given the speed and we want to calculate the frequency. The speed of both waves is given to be 12 meters per second. They have the same speed but different wavelengths, so their frequencies will differ. So we know the frequency of A is its speed v divided by its wavelength lambda A. This is the speed of 12 meters per second divided by its wavelength of 2 meters, which gives the frequency of the wave to be 6 hertz. Now we can do the same for wave B. The frequency of wave B is, using the same equation, the speed of the wave divided by its wavelength. So Fb is equal to the same speed v divided by lambda b, which is the speed of 12 meters per second divided by the wavelength, in this case, is 4 meters. And so the frequency of this wave is lower than wave A, and this frequency is 3 hertz. So a higher wavelength means a lower frequency. Now finally, in part C, we want to find the maximum speed for any particle in simple harmonic motion on those waves. Now we know Vmax, the maximum speed, is the amplitude of the wave times the angular velocity omega. And we are given from, or we can find rather, from each diagram, the amplitude for each wave. So the amplitude of wave A, AA, is 0.5 meters. The amplitude of wave B, AB, is 0.25 meters. So now we can calculate the maximum speed that any particle traveling on the waves will achieve. So for wave A first, we have Vmax to be the amplitude of A times the angular speed of A, omega A. So this is the amplitude of A, and we know we can write the angular frequency as 2 pi times the frequency of A. So this is 0.5 meters times 2 pi times the frequency of A, which we calculated to be 6 hertz, which means we get the maximum speed for wave A to be 19 meters per second. Now we'll do the same for wave B. Again, the maximum speed, Vmax, is equal to the amplitude of the wave times the angular frequency, omega b. And this is equal to the amplitude times 2 pi times the linear frequency, Fb. Again, we know all these values. That's the amplitude of 0.25 meters multiplied by 2 pi. We've calculated the frequency of wave B to be 3 hertz. This gives us the maximum speed of wave B to be 4.7 meters per second.